Good afternoon. Thank you for coming back to our class. And next week is study break, right? So we're glad that you have some time to catch up, and I have some time to catch up with work. Okay. So last week we started. We we spent the bulk of last week on risk management, and risk management is a good topic from teacher's perspective because it is relatively easy for me to set exam questions, and also a good exam questions is something that I can mark more easily because some questions it may be too abstract, very difficult to mark. But risk management was a topic that I can I can give out questions that have very clear cut, correct or wrong answers, so I can mark very consistently. And we discuss RUBS, which is a departure from the conventional waterfall model, okay? Because waterfall model requires us to primarily finish requirements before we start design and so on. But RUBT allow us to sort of spread out the requirement work, spread out the design work through the timeline. So this diagram shows the four phases in timeline. So horizontal represent the time and vertically represent the different disciplines, okay, different activities. So you can still do design activities quite late at the end of the construction time. So construction is the implementation or coding, okay? And almost at the beginning of transition, you can still do some design work. So it is different from the waterfall model. And so it gives more flexibility, okay? And so today we're going to look at another model that actually exists before RUB, okay? And why do we, because there are many people propose many different models already. So why do we pick, let's say, this one to discuss? Frankly, this is not actually a popular model that people used, okay? But the thinking in this model is very advanced in its time. So after Professor Boehm from U of Southern California, USC, one of the very famous university in United States. But USC is not only famous, but it's also famous for being rich people's university. So rich people send their kids to USC, U of Southern California, and his work influenced many other subsequent model. In fact, it affects how RUB was defined. Which part of it is most advanced? I would probably say the interactive component, the incremental component, and risk management component in the spiral model actually make it stand out. And so let's look at a diagram. Okay, so that is the spiral model, and it got the name of spiral because you can basically follow the line from the origin here. It goes around like this, like a spiral. Okay, and by the label on the spiral on the different quadrant, you can sort of get some idea of what activities happen. So initially, you somehow okay, that's better. Somehow, when you you start from the conception of requirements, and then you think about operation, and you create a requirements plan. From there, you create your first prototype. The word prototype, whenever you see a new name or a name, try to find out the exact meaning, okay, so that you from the future, from this point on, you can use the term correctly. So don't just hear a term and assume you know. The word prototyped, in fact, there is an approach called prototyping approach. Prototype means before you build the real object, you build something that looks like it, okay? It looks like the real object that you're going to use, but it may not have the real thing. Can I ask a show of hand? Any one of you was in set sail last week? Anyone attend that? 冇人啊？哇！你哋係 was it because you have class conflict? No, you just don't go. Okay. That set sail. 你又冇睇我做節目啦 ，OK？ So I was the moderator interviewing two graduates, and well, I guess it's too late unless you're staying for next year. So what with the two students that graduate from us, as it turns out, one of them work on something called front end, and the other work on back end. So let's remember these two terms, okay, in the future. Front end means roughly, very roughly, the user interface that the user is going to use. So if you're using a software, then the user interface is the front end, okay? So sometimes as a programmer, you may be hired to work on front end. So that's what one of the graduates that I interviewed last week did. And the other student worked on the back end. So back end referred to how the business logic is implemented behind the scene. So those are the things that's called by the front end. So the front end is the user interface. So I click, I enter something, and then that page will make an API call to call the back end. So you can think of how a piece of software is divided into two parts. The front end look after interacting with the user, and the back end look after actually doing the real work. Okay, so why we talk about this when we define prototype? When we look at prototype, you can think of it as a front end without the real back end. Okay, so we just try to build the user interface to show to our customer, our end user, to get them to have a feeling of what the real product will look like. So I think so prototype sort of means it's not the real thing, but it just looks like the real thing. So how about those real numbers? And what happened if you enter something, okay, to the user interface of the prototype? What will happen? Well, that means when you try to do something with the prototype, it will not actually save things in the database. So maybe you create a record with the prototype and you press create and save. And next time you try to pull out the record is not there because the back-end portion is not there yet. So prototype means you have the front end, but the back end is like fake, okay, is make-believe. Maybe the prototype program just have some hard-coded data. It never really retrieve the real data from the database. It never really saved the data back to the database. It just hard-coded everything. If you see any data on the UI, it's just hard-coded. So that's prototyping. So this spiral approach, use prototyping, give it to the users. For what reason? Well, because with a prototyping, you can discuss with the users what they like or what they don't like. So before building the real operation, the real product, okay, the real product come out here, you can have, let's say, 3 stages of prototyping, okay? Then this, each time you just improve the prototype, you use the prototype as a way to discuss with your customer how the product should be built. Because one of the worst problems in software development is we work very hard and we create a decent product, but then that product does not serve our customer. So that is bad, right? We build something good, so but it's not useful because it's not meeting their needs. So by showing them the prototype, and we can find out what they really want, or they can find out. Because one problem with users is that when I tell you I want something, well, when you actually follow my instruction to create that product, maybe when I see it, I find out I only like it 80%. Okay, it's not 100% of what I really want. So this is this sort of problems happen. Okay, when your customer tells you what they want, when you build everything exactly as they said, they may tell you, well, I still want this change a little bit. Okay, and with the prototyping approach, or the use of prototype in the spiral, it eliminates that problem, okay? Because this is just the UI, that just building the front end is sort of cheaper than building the front end and the back end. So it reduces the work by half or even more than half, okay? And after that, you go through the process of verification and validation, which checked whether the prototype is doing the right thing in the right way for the customers. Okay, so and as you progress to the planning part, you start from requirement plans, and then the development plan, and then the test plan. So this is how the spiral approach works. And only in the last round, you actually go through the design, coding, integration, testing, and here implementation does not mean coding, okay? It means transition, okay? So I think I probably mentioned that sometimes in software engineering, we have a small problem that people use implementation or use same word to mean different thing. For example, this implementation here actually it corresponds to the transition in RUB, okay? So sometimes we have, but for example, in this diagram, implementation really means coding, okay? So there are different sort of small differences when we use by different authors. So you have to be aware of the difference. And okay, so that is spiral model that affects the development of other things. And well, another thing is you can think of this one round around this is an iteration. So iteration, why iteration is very important? Because iteration, it gives you the more frequent interaction with the customers. because in the waterfall model, you probably only work with the customers in the requirements mostly, and then a little bit in the design. But on the other part, in the coding part, the big part of coding, you probably don't talk to the customer that much. And if without the iteration, the coding part can take 5 months, 6 months, and during those 5-6 months, you don't get much feedback from the customer. But here, if we use iteration approach, if your iteration is 1 month each iteration, that means every month you get to talk to the customer, you get to get their feedback. So iterative approach sort of increase the frequency you deal with the customer. So that is very good. Okay. So that let me stop this and save it. 但係有冇同學覺得咧？我正話講咗一大堆嘅嘢咧，如果我考試問翻你咧，你會唔會答得到出嚟㗎？係啦，咁我都唔會要求你哋答得到出嚟嘅。咁但係嗱，譬如 let's say because some of the stuff I will tell you more than once, okay? Lots of these stuff I told you more than once. And then in the exam, as long as your stuff is not totally different, like your answer is some along this line approximately, you'll get credit already, okay? So in software engineering, if you ask people same question, the more abstract, the more high level is the question, actually the less consistent answer you will get from different people. So I think 讀 software engineering 咧，你可以話個強處同亦都係佢嘅弱點。即係譬如，如果你讀第二啲 programming 嘅科目咧，你一答咗個問題嘅時候咧，啱就100分，唔啱就可能係0分咁樣。OK， 即係嗰一題嚟講。但係喺 software engineering 嚟講咧，就係、是、你合理嘅時候 ，OK， 又或者只要你講嘅嘢咧，同之前嗰啲 author 所講嘅嘢係有一啲嘅吻合嘅時候，你嗰啲嘢合理嘅時候咧，你可能就已經可以攞8-90分。即係所以讀呢一科咧，有少少似係我哋 computing science 入邊嘅最似文科嘅題目啦。OK， 即係或者你嗰個 approach 亦都係，即係你唔可以話邊一篇文章或者邊一首詩係寫得最靚嘅詩或者寫得最好嘅文章。OK， 即係software engineering 亦都係有咁樣。OK，so let me save that before we go on to the next part.